Welcome to part 6 of factorization. In this video, we explore the quadratic formula and the undetermined coefficient methods and solve 7 examples. Hello, math champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, this is the 6th session for the topic of factorization. In this session, we are going to focus on how to use the quadratic formula as well as the method of undetermined coefficient to do the factorization. Question 1 is to factorize a polynomial with the fourth power in real number. Remember, do not expand algebra expression straight away. We need to carefully observe this question and find a proper starting point. Both parentheses has the term of x squared plus x. We group them and do the partial expansion as shown on the screen. It is now in the form of a quadratic trinomial, but with the sum of x squared and x as a variable. You may name it to another variable or just leave it as it is. Up to this step, the cross product method can be applied to factorize the trinomial, and it has been done as seen on the screen. After rearranging them, we find the factor of x squared plus x minus 2 can be further factorized using the cross product method, and then we finalize the factorization. Example 2 is to factorize a binary quadratic expression x squared minus 2xy minus 8y squared minus 2x plus 14y minus 3. To factorize this type of binary quadratic equations, the method of undetermined coefficient can be applied. Here we demonstrate how to use this method by going through this example. The first step is to factorize the terms of x squared minus 2xy minus 8y squared by using the cross product method. The second step is to add two undetermined coefficients a and b to the factors of x plus 2y and x minus 4y respectively. The third step is to expand the two factors along with the coefficients a and b. Now the next step is to compare all the coefficients of the expanded binary quadratics to the original quadratics, and hence two simultaneous equations can be established accordingly. Undetermined coefficients a and b can be solved and determined in this way. However, we need to verify the calculated values of a and b by checking if they match with the constant terms in the original binary quadratics. Finally, we have complete the factorization. Example 3 is a similar type of question. I suggest you try it out yourself. However, I just briefly explained it here straight away. Factorize the first three terms x squared plus 5xy minus 2y squared using the cross product method. Then two undetermined coefficients are added to these two factors accordingly, and assume that it equals to the original binary quadratics. Expand these two factors and rearrange them. Since the two binary quadratic forms are exactly the same, their corresponding coefficients must be equal to each other. Hence, two simultaneous equations are established for this purpose, and both values of a and b are calculated and determined. Finally, don't forget to verify the calculated coefficients against the constants in the original binary quadratics. Example 4 is to factorize an algebraic expression with the variable x to the power of 4. As I demonstrated earlier, careful observation is always helpful to find a better starting point to solve mathematical problems in general. First, we see the factor x squared minus 9 can be factorized to x minus 3 times x plus 3. Then we group the factor x minus 3 together with the factor 2x plus 5, while the factor x plus 3 is grouped with the factor 2x minus 7. Here we use two sets of square brackets to group them. After expanding the factors in each square bracket, we have 2x squared minus x in both parentheses. They are showing in red color here. And we use them as a composite, or say a mixed variable, and then expand and rearrange the expression to get the quadratic trinomial form. However, the variable in this quadratic trinomial form is 2x squared minus x instead of x. Since we cannot apply the cross product method to factorize this quadratic trinomial, we introduce a new factorizing technique here, which is the quadratic formula method. First, we need to check its discriminant and see if it is greater than or equal to 0. We use the symbol delta to represent this parameter. If the delta is greater than or equal to 0, then the trinomial is qualified to be factorized in real number range. Now we have the discriminant of trinomial, which is equal to 72. Based on the quadratic formula, the factorized form of this trinomial form can be written down straight away, and it is simplified as displayed on the screen. Now let me briefly explain about the formula method as we just used to factorize the quadratic trinomial. We start from the general quadratic expression with coefficients a, b, and c. As did in the early session, we take the quadratic coefficient a out and then add and subtract a constant term showing in red in order to make the form of a complete square minus a constant of b squared minus 4ac, or in parentheses over 4a squared. As 4a squared is always greater than 0, then if the delta is greater than or equal to 0, so the quadratic trinomial in general can be factorized as shown on the screen. In case the delta is less than 0, then the factorization is beyond the real number range. Example 5 is to factorize a polynomial expression with x to the power of 4. Here we have observed that x plus 1 can be replaced by x plus 2 minus 1, while x plus 3 can be replaced as x plus 2 plus 1 as shown on the screen. In order to simplify the calculation later on, we assume a variable a as x plus 2. Then the polynomial expression can be written as a minus 1 to the power of 4 plus a plus 1 to the power of 4, then minus 272. We recall the formula of expanding a plus or minus 1 to the power of 4 as shown on the display. As it can be seen, the cubic and the linear terms have plus and minus signs. They will be cancelled out after both complete force power being expanded. So after expanding and simplifying, we have 2 times open parentheses a to the power of 4 plus 6a squared minus 135 close parentheses. It can be factorized using the cross product method as shown on the screen. Hence, it can be factorized to 2 times a squared plus 15, or in parentheses times a squared minus 9, or in parentheses, which can be further factorized to a plus 3 times a minus 3. Example 6 is to factorize a polynomial x to the power of 4 plus 100x squared plus 99x plus 100. If we remember the formula of the sum and difference of two cubes, we need to subtract and add a term of x as shown in red color here. Then we group them using two sets of parentheses. The next step is to factorize in each group. For the first group, x is the common factor, and then the remaining part is x cubed minus 1, which can be factorized as x minus 1 times x squared plus x plus 1, or in parentheses. As for the second group, we just take out 100 as its common factor, and the remaining part exactly matches the quadratic factor in the first group as shown in red color. Hence, we take out the common quadratic factor and complete the factorization. Example 7 is the similar type of factorizing question. As we did in example 6, we add and subtract a term of x and group them accordingly as displayed on the screen. Then we factorize each group and find both of them have the same quadratic factor x squared minus x plus 1, which is shown in red color. Finally, we factorize the entire expression by taking out the common quadratic factor. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.